Hello, this video corresponds to the second session of topic 3 about energy in MEDEAS. In the previous session, some theoretical concepts about energy was explained. In this video, how the energy part is modeled in MEDEAS will be explained. In this session, we take a quick look at the main features of the energy module in MEDEAS, the modeling of non-renewable energy sources, the modeling of renewable infrastructure for electricity and heat, and the different types of biomass considered in MEDEAS. In the first topic, the whole scheme of the MEDEAS model was explained. Topic 2 looked at the economy module, and this topic focuses only on this part of the whole model, energy availability and energy infrastructure. The main objective of the MEDEAS module is to obtain the energy consumption necessary to cover the economic demand. For this, the required energy demand is obtained in the economic module through the energy intensities, as explained in the second topic of this course. The energy demand is disaggregated by 5 types of final energy: liquid, gases, solids, electricity, and heat. Each demand is compared with the availability of energy. In MEDEAS, renewable energies have priority over non-renewable energies. 23 energy sources have been modeled in MEDEAS. Once the energy demand has been compared with the energy availability, the real consumption is obtained. Apart from that, energy availability is limited in MEDEAS in both non-renewable and renewable sources. The maximum extraction curves limit the non-renewable resources through Huber curves, while the renewable sources are limited by the maximum potential. Huber curves and maximum potential concepts was explained in the previous session of this topic. This slide shows all the primary energy sources that have been modeled in MEDEAS. They are classified by renewable and non-renewable sources and by type of final energy. Renewable energy sources are not only considered for electricity and heat generation. Renewable energy sources are used for the 5 types of final energies in MEDEAS. For example, biofuels for traditional biomass, bioliquids, biogas are considered. There is also a disaggregation of non-renewable energies. For example, oil and natural gas are separated by conventional and unconventional resources. Let's start by explaining how non-renewable energies are modeled in MEDEAS. Oil, natural gas, coal, and uranium are the 4 types of non-renewable primary energy sources considered. The modeling is based on Huber curves, which tell us the maximum extraction of that resource that will be reached each year. Also, the remaining ultimately recovered resource can be obtained with the Huber curves. The Huber curves have been converted into maximum extraction curves in MEDEAS where, basis of the remaining resources, the maximum extraction of the resource is obtained. The figure on the left shows the Huber curve for La Herrera 2018 for natural gas, and the figure of the right shows the natural gas extraction curve for La Herrera 2018. In MEDEAS, the user can select the extraction curve for each energy. For example, the user can select the mentioned La Herrera 2018 gas extraction curve. This slide shows in a simple way how coal extraction is modeled in MEDEAS. On the one hand, the demand for solids is obtained through the economic module. The part of this demand covered by renewable energy is subtracted and the required demand for coal is estimated. On the other hand, the user chooses the maximum extraction curve from which the URR and the maximum annual extraction are established. Then, the model compares the maximum extraction of coal with the required demand of coal, and the extraction of coal is obtained. The coal extraction is then used to estimate when the scarcity of coal begins. Also, the real consumption of emission derived from coal are calculated. In this slide, the graphs with the extraction of oil and coal are shown. It can be seen how the maximum extraction curve, the green line, limits the extraction of the resource, the red line. If the required demand is less than the maximum extraction, all the demand for resource will be covered. While, if required demand is greater, the extraction of resource will be adjusted to the maximum curve. In the case shown in this slide, the oil is limited by its maximum extraction curve, while coal is not limited. Having briefly discussed the modeling of non-renewable energy sources, the modeling of renewable energy will now be explained. We start with renewable energies for production of electricity and heat. In MEDEAS, 8 types of renewable energies are considered for electricity, such as hydro, solar PV, solar CSP, onshore wind, offshore wind, geothermal, biomass, and oceanic, while for heat, 3 sources are considered: solar, biomass, and geothermal. Renewable energies require infrastructure to be extracted. The greater the amount of such infrastructure, such as windmills, solar panels, etc., the greater the energy obtained. But such equipment needs time to be set up, which is why in MEDEAS they are considered as stock and are built according to the rate of investment infrastructure. Several factors limit the development of these infrastructures. One is the absolute technical potential that has been established in MEDEAS for each technology. Another is the rate of growth, which is determined exogenously according to the different scenarios. If the build-up of the new infrastructure is slow, the technical potential might not be reached by 2050. And if the depletion of fossil fuels is faster than the establishment for renewable energy, shortage cannot be avoided. However, renewable energy sources development in MEDEAS is limited by other 2 factors: intermittency and the contribution to the energy mix. This might make the renewable energy infrastructure development by the end of the simulation lower than indicated by the policy, because this factor inhibits the development of more intermittent energy during the simulation. This slide shows, in a simplified way, the modeling of the infrastructure for the generation of electricity. As said before, the user defines exogenously what the defined value of the growth of renewable energy is. However, the growth is limited by above mentioned aspects. Firstly, its technical potential. When the generation of one energy source is close to its maximum potential, the growth is limited. Secondly, its contribution to the energy mix. For example, if electricity generation by renewable energy is close to the total electricity demand, the growth is again limited. Finally, the growth of renewable energies is also limited by the intermittency of some of these sources. The increase in the capacity of the renewable energies will also depend on the time for planning and the construction of the infrastructure. As an example of the results in MEDEAS, this slide shows the evolution of the installed capacity of renewable energy sources for electricity, considering a scenario with a high growth of renewable energy. The installed capacity will grow over the next decades, especially in the solar PV and onshore wind cases. In 2050, the installed capacity for solar PV will be almost 20 terawatts. We finished this session explaining how biomass production is modeled in MEDEAS. Biomass is considered for both the production of liquids and gases and for its use as solid fuel. The liquid fuels considered in MEDEAS are second and third generation biofuels derived from food crops, the biofuels obtained from woody parts of non-food biomass residues, and the biofuels that can be obtained in marginal lands. The evolution of biomass is also modeled in MEDEAS, while solid fuels are used as traditional fuel or to obtain electricity and heat as mentioned in the previous slides. Both the growth of different types of biomass and their maximum potential can be defined exogenously by the user. As an example of biomass modeling, this slide shows the production of biofuels in marginal lands, which refers to lands with little agricultural value. On the one hand, the user will have to select the year in which the marginal lands will begin to be used for biofuels and the annual growth of the production. With these variables and with respect to the productivity of the land, the production of the biofuels is obtained, which in turn is limited by their maximum potential. Finally, the primary energy required to obtain this biofuel production is also calculated. Finally, the figure of the left shows how the production of biofuels evolves, the green line, and the primary energy that has been required to obtain this biofuel production, the red line. As shown in the graph, the primary energy required is much greater than biofuel production, in fact, about 6 times more. In addition, the figure of the right shows how the production of biofuels covers a very small part of the total demand of liquids. In this topic 3 about energy, in the first session we explained the great importance of energy in the development of the humanity and our societies, the current stagnation in non-renewable energy sources production, and the peak oil concept, the energy return of energy investment concept, and the challenge of renewable energy sources for filling the gap left by the another energy sources. And in the second session, we describe the main features of MEDEAS model in MEDEAS and explain the modeling of non-renewable energy sources, renewable infrastructure for electricity and heat, and the different types of bioenergy considered in MEDEAS. And with this, we finish the energy topic of the MOOC.